924. Wastewater treatment plant will receive a flow of 35,000 meter cubic per day. Okay, which means 10 million gallon per day. With a raw wastewater CBOD5 is 250. So the influent BOD is 250. Primary treatment removes 25% of BOD. So the primary treatment, as we just mentioned before, the raw wastewater will come from the side. First of all, it will go to the primary tank, and then to the aeration tank, and then to the secondary clarifier, and then leaves the plant. Of course, what's recycled is from here back to the aeration tank, and wasting is here. There's some sludge coming up also from the primary tank. So the flow is given. The BOD5 entering is 250. So BOD5, he has the carbonaceous BOD5, which is also type of food. Primary treatment removes 25% of the BOD. So BOD leaves here, 25% will be gone with the sludge at the bottom of the primary tank, and the rest will go to the aeration tank. Calculate the volume. You need to know the volume, the approximate hydraulic retention time in hours for the aeration basin required to run the plant as a high rate facility. F over M, okay, 2 kilogram BOD per kilogram MLSS per day. Okay, and the aeration basin MLSS concentration will be maintained at 2,000 inside the aeration tank. So it's 2,000 milligram per liter, MLSS per liter. Okay, so how could we approach this problem? First of all, we have to find out, let's see, the first one is to find out the BOD entering the plant and the BOD leaving the primary tank toward the aeration tank. So let's find out S naught. So S naught is equal 250 milligram per liter. If 25% leaving in the sludge, what is coming here? 75%. So this is times 75%. Okay? Now, this would give you 0.75 calculator, 75 over 100 times 250, and that is 187.5 milligram per liter entering the aeration tank. Okay, so now what else we need to do? So this is the BOD entering the aeration tank. Now let's put the equation of the F over M. F over M is equal Q naught S naught Vx. So we have S naught. And the flow rate, do we have the flow rate? Let's see, yes, 35,000 meter cubic per day. Do we have F over M? Yes, it's 2 kilogram. This is not 5, this is 2, so F over M is equal to 2 kilogram BOD per kilogram MLSS per day. And volume is unknown, and X is whatever is inside the aeration tank, 2,000 milligram per liter. We have to watch for units. So F over M is 2. Let's put it kilogram, 2 kilogram food BOD over kilogram biomass day equal Flow rate 35,000 meter cubic per day. Okay, times S naught. S naught is 187.5 milligram per liter. Okay, divided by volume unknown. And X is 2000 milligram. And remember, the 187.5, this is milligram BOD5. And this is 2000 milligram per liter, milligram MLSS. This is food, and this is biomass. And you cannot cancel out milligram this with this milligram. Okay. You can see here on the other side that kilogram BOD5. And here milligram BOD5. So you have to convert this milligram at the top to kilogram. 1 kilogram is equal 10 to the 6 milligrams. So now kilogram BOD5 is equivalent to this side, kilogram BOD5. Let's see here you have kilogram MLSS. So you have to convert milligram, kilogram, 1, 10 to the 6. Now milligram SS, milligram SS. Now we have kilogram with kilogram MLSS. Day and day, you don't have to cancel. You don't have to change. Everything else right now, liter is gone with liter. What do you end up with? You'll end up with meter cube. So the answer is like this. Now, we know that units are consistent. So 2, and you can see the 10 to the 6 will cancel out. So 35,000 times 187.5 over volume 2,000. So now volume is equal 35,000 187.5 over 2,000. Okay, now let's look at this and calculate the volume. 35,000 times 187.5 divided by 2,000 divided by 2. So you will have a volume of 1,641 meter cube. So 1,641 meter cube is the volume of the aeration tank. Now, let's look at the next part of the question. Now we want to find out the hydraulic detention time. The hydraulic detention time, as we know, it's volume over Q. So volume is 1641 meter cube, and volume and flow rate is equal to 35,000 meter cubic per day. This cancel with this, you'll end up with, of course, 0.047 day, and you could do day and hour. 1 day is 24 hours. You'll end up with 1.1 hours. This is the detention time of the aeration tank. Of course, this detention time is the approximate number of hours. Of course, because the flow estimate does not include any retained activated sludge with it. So this is the answer for this problem.